Hey everybody, this is Mr. Chernitzky, and this is Unit 3, the Unit Circle. So this is just an introduction into what we call the Unit Circle. If you take a trigonometry course, you'll get a far more in-depth version of the Unit Circle, and it will include things like radians, and you'll get to see what it's used for. But since we in geometry have just started talking about circles, and we just finished up a unit that had special right triangles, I figure this is the best time to at least introduce you to the concept of a unit circle. That way, if you ever see it in the future, it'll be somewhat familiar to you. Okay. Alright, so before we look at the unit circle, let's take a look at these three special right triangles. The first one is a 30, 60, 90 triangle, and it's got a hypotenuse of length 1. So here's our triangle. I'm just going to highlight it in red, and it's got a hypotenuse length 1, and we need to solve for the other two sides. So first thing that we do with special right triangles, we draw our reference triangle. So short leg is 1, hypotenuse 2, long leg root 3. Now remember that going from hypotenuse to short leg, we divide by 2 because the short leg is always half the length of a hypotenuse in a 30, 60, 90. So y is going to be really easy to solve. It's just going to equal 1/2. For x, we're going to set up a proportion. So we'll put x over root 3 since that's what it matches up with. And then I need to pick two other sides. So I'm going to pick the two hypotenuses. So on our original triangle, our hypotenuse is 1. And on our reference, it's 2. So we got x over root 3 equals 1 over 2. We'll go ahead and cross multiply. So we get 2x equal to root 3. We'll divide by 2. And so we get x is equal to root 3 over 2. Okay. Let's take a look at our 45, 45, 90 triangle. Again, the hypotenuse is length 1. We'll go ahead and draw our reference. And for a 45, 45, 90, our reference is 1, 1, and then hypotenuse root 2. So if I'm solving for y is going to match with 1, so y over 1, equal to the hypotenuse 1 over the hypotenuse root 2. I could cross multiply, but I've already got y is over 1, so really y is already by itself. So we have y equal to 1 over root 2, which would be a correct answer, except we're not supposed to leave a radical in the denominator. So the way that we fix that is we multiply the numerator and the denominator by that radical, so radical 2. And so we end up with y equal to root 2 in the numerator, and in the denominator root 2 and root 2 gives us whole number 2. So there's our answer for y, which coincidentally it's going to be the same answer for x. Actually, not coincidentally, we know it's got to be the same because this is an isosceles triangle. Okay. Alright, so we got our first two triangles solved. Let's go on to the last one, which actually we don't need to really do too much work on because this is the same 30, 60, 90 triangle as the red one. It's just been tilted and flipped over around. So x is going to be equal to 1/2. And y is going to be equal to √3 over 2. Alright. So now what we're going to do is, for our unit circle, we're going to take these three triangles in the first quadrant and superimpose them down. So I suppose I should talk a little bit more about what our unit circle is. So the unit circle is a circle with radius 1, so that's why it's a unit, 1 unit circle. And it's centered on the origin. So in other words, if we drew our coordinate grid lines, our circle would be centered right where the x and y axis cross. In other words, the center of our circle would be at 0, 0. Since our radius has, our circle has radius 1, wherever these arms go on our axis, it's really easy to figure out what the coordinates are. So over here at 0 degrees, that would be a x of 1 and a y of 0. At 90 degrees, we would have an x of 0 and a y of 1. So in other words, this point here at 0 degrees is 1, 0. And up here at 90, we have 0, comma 1. Over here at 180, that would be negative 1, 0. And down here at 270, that would be 0, negative 1. Okay. What about these in-between angles here? So first thing, notice that it's convention, as we're going around the circle, we start at the right-hand side, so we're like the 3 o'clock portion of the clock, and we go counterclockwise and increase our angle going this way. So 30, 45, 60, 90, and then it keeps going all the way around until you reach the very end at 360. Okay, we're mostly going to focus on the first quadrant because everything else is really just a mirror of that first quadrant. So if I take that red triangle that we drew and I superimpose it, a little better, superimpose it on my circle here, you can see my radius of 1 is going to fit it right at the edge there. And the distance in the x here, the horizontal distance, would be √3 over 2, and my vertical distance of y would be 1/2. So essentially this point at 30 degrees would have the coordinates of √3 over 2 and a y coordinate of 1/2. We do the same thing with our green triangle here at 45 degrees. Our horizontal distance would be √2 over 2, and so would our vertical distance. So those would be the coordinates at this 45 degree angle. And finally, our 60-degree angle. We would use our 60-degree triangle. So that would have x of 1/2 and a y of √3/2. Now your assignment is going to ask you to fill in the rest of these numbers. I'll show you how to do it, but you could also just look it up on a table, or sorry, on Google. Just look up a picture of the unit circle. So this first coordinate over here, if we looked at 120, essentially this would be a mirror of our blue triangle here. So same coordinates, 1/2 and √3/2, except that we're in the negative values for the x. So this would be a negative 1/2 and then a positive √3/2. If we looked at the green, or the 135, that would be a mirror of our green triangle. So the coordinates are going to be the same, √2/2 and √2/2, except that our x is going to be negative. So negative √2/2 and then positive √2/2. Finally, at 150, that's a mirror of our red triangle. So the coordinates are going to be the same, √3/2 and 1/2, except the x coordinate is negative. Okay. You could do the same thing for the bottom half of the circle. I am personally okay with you guys also going and just doing a Google of the unit circle. And you should find plenty of pictures that are going to show us so you find it. Oh man, you got a complicated version. Anyway, there you go. So you have the full unit circle here if you just do a Google search. Okay, that's it for this lesson.